So let's go over how we can find the formula for these sequences. Sometimes a pattern can lead to a general rule, and this rule is called the general term for the nth term. So in both arithmetic and geometric sequences, the value of a term depends on the value of n. So if we were to talk about it in terms of functions, the value of a term would be the dependent variable, which is denoted as t subscript n. And the value of n, the term number, would be the independent variable. So let's go over the example for an arithmetic sequence. So here we have the term numbers going across the top. Here we have the terms themselves going across the bottom. Now we already know that for an arithmetic sequence, in order to get to the next term, we have to keep adding the common difference d. So if the first term we start with is a, then the next term we would add d to a, so then we get a plus d. That's the second term. The third term is going to be another d added on. So if we were to simplify, that would be a plus 2d's. And then the fourth term, we would add another d. So then that we get a plus 3d right there. And if you continue the pattern, what do you see? This 3 and this 2, you just have to subtract 1. This 4 and this 3, you just have to subtract 1. So by the time we get to the nth term, we're just going to have to subtract 1, and that's how many multiples of d we would have added on to a. So we get the formula a plus n minus 1d. And in fact, that is the general term for an arithmetic sequence. All right, arithmetic sequences, if you think about it, the terms keep increasing by a constant number, so that means that we can represent them using a linear function. All right, for a geometric sequence now, again, we start with the initial term of a. In order to get to the next term, we need to multiply by some constant value r. So the second term is ar. To get to the next term, the third term, we would multiply by another r. If we simplify, that would be ar squared. To get to the fourth term, we multiply by another r, and we end up with ar cubed. So as you can see, if we continue the pattern, we're going to end up with ar to the power of n minus 1. Because again, in order to go from the term number to the power on, or the exponent on r, we just have to subtract 1. And that gives us the general term of the geometric sequence. If you recall way back from Unit 4, if we have an exponent that is a variable, then we end up with an exponential function. All right, so you might want to just put a little box around this or something so that you have your... Oh, my pen's running out. Better. All right, so very important key concepts. Little stars next to those.